everyone. The topic of our lecture for today is interaction diagrams, close up. We'll deal with the such diagrams as sequence diagram and cooperation diagram. An interaction diagram is a diagram that represents an interaction consisting of a set of objects and the relationships between them, including the messages they exchange. This term is applied to the types of diagrams with an emphasis on the interaction of objects, diagrams of cooperation, sequence, and activity. Sequence diagram, that is an interaction diagram in which the main emphasis is on the ordering of messages in time. Cooperation diagram, that is an interaction diagram in which the main emphasis is on the structural organization of objects that send and receive messages. Activity diagram describes the process of building a system model. So we can see that from the beginning, we fulfill a class diagram, use case diagram, and component diagram. And after this, activity diagram, cooperation diagram, state diagram, sequence diagram, and at the last, deployment diagram. Interaction diagrams. Interaction diagrams are built after the structure of the system is described. That is class diagram, component diagram, and ways in interacting. It interacts with the outside world, use case diagram. Algorithms of actions performed in the system, the activity diagram. That is, as it were, the final touch, a clarification of how exactly the system behaves by depicting the interaction of objects within it. The place of interaction diagrams in the software development life cycle. So we can see at the time of system requirement, then we can design use case diagram and activity diagram. Then we can see period of analysis with the component diagram, sequence diagram, and cooperation diagram. And then design with the class diagram and code with the state diagram, source code, and deployment diagram. Sequence diagrams and the annotation. A sequence diagram shows the sequence in which objects exchange messages during an interaction. An object is simply a rectangle containing an underlined object name and a class name that is optional, separated by a colon. Objects are located at the top of the diagram, one after another. Down from each object stretched a dotted line, which is called the lifeline of the object. The lifeline of an object is the line that depicts the existence of an object over a period of time, and the longer the line, the longer the object exists. Messages exchanged between objects are depicted as arrows directed from the lifeline of one object to the lifeline of another. Object lifelines extending down act as a timeline so that messages sent earlier are higher than those sent later. Term message. We consider a message as a specification of the transfer of information from one entity to another. An object sends a message with the expectation that it will cause some reaction and some activity will follow. Focus of control. Focus of control on sequence diagram is the long broken bars on the lifelines. Thus, periods of time are indicated when the object has focus of control. That is to say, performs some action, and it doesn't matter how, directly or by calling some subordinate operation. To draw a focus on node is a matter of habit for every designer. If an object is destroyed in the process of interaction, this fact is marked on its lifeline with a cross, which in fact ends this line. So we can see object 1 from class 1, object 2 from class 2, and object 3 from class 3. All of them have their own lifeline, and the lifelines of object 1 and object 2 hasn't end, and the lifeline of object 3 has end. Destruction of object. And first message from object 1 to object 2. Then we can see at the lifeline of object 2 focus of control when object 2 fulfills some action, activity. The next examples of notation, that is maybe anonymous actor, not the object which is known by us, but anonymous actor. And also at the lifeline of object, we can see reflecting message, that is the message from object to himself. That is example of this activity, maybe timing or other activity inside this object which has the end of this activity. Reflective message, reflection, that is introspection. Object sends a message to itself. This is how they draw if you need to show an action performed by the object itself or inside it, or that the object introduces itself into a certain state. Another example of sequence diagram. We can see object buyer and cash register, credit card terminal, and bank branch. And we can see three options. If buyer has the price of some goods and price low or equal 100, then it plays by cash in cash register. If price more than 100 and low or equal 1000, then buyer make a cashless payment to credit card terminal. And last option, if price more than 1000, then buyer pay by loan processing with the bank branch. Response messages are usually represented by a dotted line with an arrow, although they are often exactly the same as regular messages, just pointing in an opposite direction. How exactly to draw them, with a dotted line or a solid one, is up to you. It's absolutely not important. The only condition that it has to be understandable to you and the surrounding workers. So we can see the previous diagram, and we can see response message from bank branch to buyer denied is message. Types of messages. First type, synchronous messages. Suspend the thread of execution until a response is received. Synchronous messages are displayed as a solid line with a triangular filled arrow at the end. Next type, asynchronous messages. Don't wait for a response. Don't suspend the flow of execution. Immediately after they are sent, an immediate transition occurs to the next step and the sequence continues. Asynchronous messages are displayed as a solid line with a regular composed of two segments, a row at the end. So we can see at the left side designation of synchronous messages, at the right side asynchronous message. And as an example, a reply message at the center, and this reply message is synchronous because filled triangle at the end. Next type of messages, lost and found messages. Example, for example, seller send message, help me please, and it's write some message at the paper, uh, get it to the some box and throw at the water. That is lost. And next type of messages found. We don't know from whom this message. For example, for official, for your information. Cooperation diagrams and their notation. Cooperation diagram, collaboration diagram, and communication diagram. The word cooperation means joint activity. Such diagrams show how objects work together to achieve a common goal, focusing on their roles. I intended to describe the dynamic aspects of the system being modeled. Collaboration diagrams show a set of interacting objects in a real environment from a bird's eye view. Distribute functionality between classes based on the results of studying the dynamic aspects of the system. Describe the logic for performing complex operations, especially in cases where one object interacts with several more objects. And also study the roles performed by objects within the system, as well as the relationships between objects in which they are involved in performing these roles. Speaking of collaboration diagrams, two levels of such diagrams are often mentioned: the level of instances and the specification level. The instance level reflects interactions between object class instances. Such diagrams is usually created to explore the internal working of an object-oriented system. And next type, specification level, is used to study the roles played in the system by the main classes. Cooperation. This is a static construct for modeling a set of entities interacting with each other. A collaboration defines a set of interacting roles used together to show some functionality. Cooperation often implements some design pattern. Cooperation is depicted as an ellipse with a dotted border, and we have two ways of displaying. Here you can see cooperation as a set of roles used together to show some functionality. In this case, performing monthly backups. So we can see surrounded dotted line and the name of this cooperation, monthly backup, and who make this cooperation, computer, software, and disk drive. Roles attached to the object classes within the framework of this cooperation. Role assignment is represented by a dotted line with an arrow at the end, directed toward the object. The role name is indicated at the end of the line, next to the object. So we can see cooperation with the name sale of goods. And buyer fulfill the role of client, and salesman fulfill the role of manager. And we can see inherited from this, from sale of goods, we can see cooperation selling a computer, salesman, and inherited from a computer equipment seller. The role is the same, manager, and a buyer of personal computer that with the role the same, client. Here you can see another example of interaction diagram. And we can see that a customer create an order checkout, and if credit card payment, then a message will go to the payment processor with the received and commit. And we can see first message get total to the order, and the order total calculate total, and then order checkout display checkout page, and also we can see order item and message to it get total and get info, and get price, number ordered, and get info. These messages go to the item. In the diagram of cooperation, the order of messages is displayed as follows. Just write its number before the title of each message. This construction looks like this: number, message name. Composite numbers are often used as well. For example, an object sends the message number 1 to another object. When the receiver object in turn sends messages to the object, they receive number 1.1, 1.2, and etc. To mark parallel message streams, their numbers are preceded by the letter A, B, C, D, and etc. So we can see another example of collaboration diagram, and we can see that the first message with the number 1 with the name car arrival, it go to the controller, and then in parallel A, B, C, D messages, and the first messages, for example, to the circle light, to the traffic light, and also light traffic lights to the another direction of the lights. And also we can see 3 circle to work signals to the people, and from one direction, and walk signals to another direction of the road. Next definition of multi-object. Multi-object shows that at the far end of the association there is not one, but a whole set of objects. This construction is used to show an operation that targets a whole set of objects. Multi-object depicted as 2 rectangles offset from each other, which give the impression of a deck of cards. A message sent to a multi-object means a message to a set of objects, for example, a selection operation searching for a specific object. Here you can see example of collaboration diagram, and we can see that first message with the name printer choose to the some number of printer, and a second message with the command print go to the specific printer, which is aggregated to this number of printer which have received the first message. Suppose now that we have several network printers and one local printer available. How to show that the was chosen? To do this, use links with stereotypes. So we can see that first message was choose, and second concrete message to the local printer with stereotype local. Relationship stereotypes allow us to eliminate the ambiguities that could be if we were talking, for example, about a multinational distributed company. So we can see object with the name C from the class company, and it's affiliated with the some number of departments with the stereotype local subdivision, and each department associated with the some number of employer. Again, we can see stereotype local does the job, and self manager to this group of employer. Next definition of composite object. A composite object is a high-level object that consists of several parts objects. This is an instance of a composite class that implements composite aggregation of a class and its parts. Composite object, that is a concept close to the concept of cooperation, but simpler and more limited. This is a construction that shows the who in the form of interacting parts, but mainly in terms of composition. A composite object is displayed as a rectangular object symbol, but with some differences. The name of the object is indicated at the top of the rectangle, separated from its rest by a horizontal line. Parts of the composite object are placed in the lower part of the rectangle, also, of course, represented by object symbols. Parts of a composite object can and even should be related. This situation is allowed when some parts of the composite object are themselves composite objects. So here we can see an example of composite window, graphic window model. We can see a rectangle with the name at the top, a window object from the class window, and we can see some object inside uh, this object. We can see a work area pane, and it moves the vertical scroll bar and moves horizontal scroll bar, and at the bottom we can see title bar. Next definition, active object. A composite object is only close in meaning to cooperation, but isn't found in interaction diagrams in its purest form. On the interaction diagrams, you can see a construction that is very close in meaning, namely the active object. Active objects are objects that own their own flow of control and can indicate the execution of actions. Passive objects hold data but cannot initiate execution. The active object, or rather its role, looks like a rectangular object symbol in the diagram but with thicker borders. Often the active object is depicted as a composite object containing part objects. So we can see active object factory manager, and it contains inside the current job, transfer job, and factory scheduler, and factory job MRG. And this active object communicate with the to another active. So again, active object with the from the class robot and the class oven, and we can see command first start and B2 completed to the robot. And in parallel, we can see first command A1 start job and A2 completed from the oven. Compose a structural diagram, show the internal structure of the element, including points of interaction with other parts of the system. That the composition and relationships between parts are displayed, which together implement the behavior of the element. So we can see example of composite diagram for the bike. And we can see inside the frame and front wheel and rear wheel, and the front wheel contain rim, spoke, sleeve, and rear wheel contain rim, spoke, sleeve, and star, and the star is connected with the chain links, and the chain links connected with the frame. That is your bicycle or bike. Next definition of port. Port is a typed element that represents the outwardly visible part of its containing element. The pod defines the interaction of the model element with its environment. A pod can be placed on the boundary of a part, class, or composite structure. A pod report can describe the services provided by the model element and required by its environment. The pod is depicted as named. It was not for nothing that we said typed earlier rectangle on the border of the model element containing it. However, sometimes you can see the pod symbol inside the class symbol. Then they say that the class has a hidden pod. So we can see designation of class and first of all part in it, and we can see at the border of the class port at the right side, and the left side we can see port as a provided interface, and next required interface. That is the same designation of some kinds of port at the diagram. Recommendation for building interaction diagrams. First step, you need to start by selecting those and only those classes whose objects participate in the interaction you are modeling. Second step, then we put all the objects on the diagram. Third step, it's also necessary to define those objects that will exist permanently and those that will exist only during the execution of actions within the framework of the simulated interaction. Fourth step, though the objects are drawn, you can proceed to the messages. Fifth step, it may be necessary to use different kinds of messages and stereotypes to better convey the roles played by objects in interaction. Sixth step, to destroy objects that exist only during the execution of certain actions, special messages must also be provided. Seventh step, the simplest cases of branching of the interaction process can be shown in one diagram. Eighth step, it's better to show each alternative flow of control on a separate diagram. In this case, such particular diagrams should be considered as complex as one model of interaction. Ninth step, if you want to make the diagram even more detailed, you can introduce time limits on the execution of individual actions. And conclusions for the theoretical material. Sequence diagram, that is an interaction diagram in which the main emphasis is on the ordering of messages in time. Cooperation diagram, that is an alternative form of presenting the information contained in a sequence diagram. Cooperation diagram is an interaction diagram that focuses on the structural organization of objects that send and receive messages. There are different types of messages: synchronous, asynchronous, and response, lost and found. Collaboration diagrams come in two levels: instance level and specification level. Cooperation is the static construct for modeling a set of entities interacting with each other. Related concepts to collaboration diagrams are multi-objects, composite objects, and active objects. This all theoretical material for today. Now a short technical break. Let me check who is present. Group 241. Albu.
Here.
Badnar. Burlaev. Гайтукаев.
Here.
Герасимовский. Горбатова.
Here.
Грамматикати. Зазуля. Караульный.
Here.
Хорватска.
Present.
Ларби.
Yes, I'm present.
Лыцар.
Yeah.
Мараренко. Сиротенко. Сивак.
Here.
Степаненко Денис.
Here.
Бодр. I
Yeah,
see
I
your
had
hand.
issues with microphone. I fixed it.
Okay, okay. What about Степаненко Денис?
Here.
Степаненко Сергей.
Here.
Швец.
Yeah.
Щевель. Димов. Чайка.
Чайка present.
Кушнир. Окей, Чайка. Кушнир Писаренко. Давыдович.
Present.
Глинка. Next group, IE 242. Балабан. Балык.
Present.
Here.
Вологжанин. Гаженко.
Here.
Гордеев.
Тут.
Окей, Гаженко. Гордеев. Ефремкин. Захадзе. Копытин. Кушнир. Левентий. Лукьянец.
Here.
Юкевич. Михайленко. Остапчук. Протопопов. Резниченко. Сапожникова. Черников. Малявка.
Here.
Прохорова.
Here.
Гаврилов. Тогни.
Here.
Okay, next group. IE 243. Алвасел. Антонова.
Here.
Антонович.
I'm present.
Базбей. Вельченко. Гаврилов.
Есть.
Голчонкова.
I'm here.
Гладковский. Денисенко. Дмитрук. Драган.
Here.
Зайцев. Ипатов. Ковтун,
Here.
Кравченко,
Present.
Кузьменко, Кучерявенко,
I'm present.
Мартыненко, Плотникова, Сирица, Сливка,
Present.
Фис, Чернега, Палас, Задорожная. First question for today. Can a sequence diagram contain an object with a lifeline but without focus of control? And first in line is Antonova. No. Antonovich. No. Gavrilov.
Is yes, because sequence diagram can contain an object with a lifeline, but without a focus of control.
Окей, Голчонкова.
А меня
Yes.
слышно?
Yes, of course.
Yes, a sequence diagram can include an object that has a lifeline but no focus of control. The focus of control is not always shown because it's usually obvious from the messages when an object is active, so adding it is optional and depends on the designer's preference.
Окей. Драган.
Yes, I also think a sequence diagram can contain an object with a life, but without focus and control.
Окей, Ковтун.
Yes, the sequence diagram can contain an object with a lifeline but without focus of control.
Окей, Кравченко.
Yes, the objects exist, but is not actively executing any operation at this moment.
И Кучерявенко.
Yes, a sequence diagram and an object can obviously have a lifeline without the focus of control.
И Сливка.
Yes, a sequence diagram can contain an object with a lifeline, but without a focus of control.
Окей, Палас. No, okay. The focus of control is often not depicted on sequence diagram. After all, it's already clear where it should be. Just look at the position of the arrows depicting messages. To draw a focus or not is a matter of habit for every designer. Next question. What is the difference between representations of cooperation at the specification level and at the example level? And first in line is Balik.
Yeah, these two are different because the difference is that representation of cooperation no, instance level reflects interaction between objects, so they can be usually created to explore internals of object-oriented system. But in any case, interaction does not depict the process. Yeah.
Okay, Газенко. No, Малявка.
The difference is that in the specification level, we just describe cooperation generally and abstractly. So these are just rules, models, maybe protocols. When the example level shows cooperation through specific cases or scenarios. So these are concrete interactions.
Okay, Prokhorova.
Specification level describes a general behavior and uses classes or roles, and example level or instance level reflects interaction between objects or class instances. Such a diagram is usually created to explore the internal workings of an object-oriented system.
Okay, Stogny.
Specification level describes the structure and roles of interaction and uses classes and relationships. And example level shows a specific scenario, uses objects with concrete values, and shows how it works with works in a particular case.
Okay. The instance level reflects interactions between objects, that is, class instances. Such a diagram is usually created to explore the internals of the object-oriented system. The specification level is used to study the roles played by the main classes in the system. In any case, the interaction diagram doesn't depict the process. It shows the interaction between objects, which is carried out by sending and receiving messages. Next question, what is the difference between active and passive objects? And first in line is Albu.
Yes, an active object, it's objects that own their own flow of control and can initiate the execution of action. But passive objects hold data but cannot initiate execution.
Okay, Bodnar.
So, passive object cannot have their own flow of control, while the active one have an instance of an active class and its process or thread of control, and can initiate control activities.
Okay, Gaitukaev.
Yeah, based on the lecture notes, I can say that active objects are objects that own their own flow of control and can initiate the execution of actions, and passive objects hold data but cannot initiate execution.
Okay, Горбатова.
Active objects are objects that own their own flow of control and can start actions on their own. Passive objects don't have their own control flow and only respond to messages from other objects.
Okay, Караульный. Ну, Хорватска. Ну, Ларби.
Yes, so active objects own their own flow and they can control, initiate execution of the actions, but the passive objects, they just respond to the actions of the active objects, so they just hold data. So yes, that's it.
Okay, Лицар. Мороленко. Active objects are objects that own their own flow of control and can initiate the execution of actions. Passive objects hold the data but cannot initiate execution. Of course, passive objects can send messages in the process of processing received requests. The active object, or rather its role, looks like a rectangular object symbol in the diagram, but with thicker borders. Next question. How is an asynchronous message different from a synchronous one? And first in line is Sivak.
Asynchronous message requires the sender to wait for a response before continuing execution. An asynchronous message allows the sender to continue without waiting for a response.
Okay. Степаненко Сергей. No, Швец.
Yes.
Please.
So the asynchronous messages not wait for response, not suspend the flow of execution. Immediately after they are sent, an immediate transition occurs to the next step and the sequence continues. And the synchronous message suspend the thread of execution until response is received.
Okay, Швец.
The difference between asynchronous and synchronous message is about waiting for a response. Synchronous message like waits until the receiver finishes, and asynchronous message don't wait.
Okay, Чайка. No, Давидович.
Yes, so I agree with previous answers. So the main difference in the flow of execution and waiting time, like synchronous messages suspend to thread of execution until a response is received, and asynchronous message don't wait for a response.
Synchronous messages suspend the thread of execution until a response is received. Synchronous messages are displayed as a solid line with a triangular filled arrow at the end. Asynchronous messages don't wait for a response, don't suspend the flow of execution. Immediately after they are sent, an immediate transition occurs to the next step and the sequence continues. Asynchronous messages are displayed as a solid line with a regular or consists from two-line arrow at the end. Next question. What is a multi-object? And first in line is Antonova.
Yes, multi-objects represent a collection of objects of the same type, usually shown as a group in UML diagrams.
Okay, Antonovich.
A multi-object represents a collection or set of objects of the same type shown as a group in a diagram.
Okay, Gavrilov.
In a multi-sequence and communication diagrams, a multi-object is a symbol that represents a collection or a set of objects rather than just one single object.
Okay, Golchonkova.
A multi-object represents not just one object, but a group of objects. It is used when an operation is applied to the whole set. A message sent to a multi-object means the same message goes to multiply objects at once.
Okay, Dragan.
Multi-object, it represents a set of objects on the many sides of association.
Okay, Kovtun.
A multi-object is used to represent a collection of objects that act as a single unit in an interaction.
Kravchenko?
A multi-object is a representation of a collection of objects shown as a single element in a diagram. It indicates multiple instances acting together rather than one specific object.
Multi-object indicates that at the far end of the association there is not one but a whole set of objects. This construction is used to show an operation that targets the whole set of objects. The multi-object is shown as two rectangles offset from each other, giving the impression of a deck of cards. A message sent to a multi-object means a message to a set of objects, for example, a selection operation, searching for a specific object. Next question, what is a composite object and how is it related to the concept of cooperation? And first in line is Kucheryavenko.
Yes, a composite object is an object that contains other objects. In UML, it represents a high-level entity that is made up of parts.
Okay, Slivka.
A composite object is a high-level entity consisting of eternal part objects that interact to implement the behavior of the whole.
Okay, Palas. No. Balik.
Yes, a composite object is an object that consists several parts. It's a construction that shows the whole form of interacting parts, but mainly in terms of composition.
Okay, Gajenko. No. Malявka.
A composite object is an object made of multiple interaction parts, and it is related to the concept of cooperation by its behavior, because it emerges from cooperation between those parts.
Okay, Prokhorova.
Composite object is a high-level object that consists of several parts objects. This object is a concept close to a concept of cooperation, but simpler and more limited. This is a construction that shows the whole in the form of interaction parts, but mainly in terms of composition.
Okay, Stogny.
A composite object is an object made out of other objects, parts that works together as a whole. A composite object is essentially a graph of objects cooperating, and its behavior emerges from interactions between its parts.
Okay. A composite object is a high-level object that consists of several parts objects. It's an instance of a composite class that implements composite aggregation of a class and its parts. Composite object that is a concept close to the concept of cooperation, but simpler and more limited. This is a construction that shows the whole in the form of interacting parts, but mainly in terms of composition. Next question, how to avoid complicating an interaction diagram with forked control flow? And first in line is Albu. No. Bodnar.
To avoid complication of integration, we can use a reference frame and use interaction diagrams to combine elements of activity diagrams and sequence diagrams. So the combination of the fragments is key in achieving complicating of the integration diagrams.
Okay, great, Tukayev.
Yeah, I can add that in simplest cases, a branching of the interaction process can be shown in one diagram, and it's better to show each alternative flow of control on a separate diagram.
Okay, Горбатова.
To avoid complicating an interaction diagram with forked control flow, each alternative flow of control should be shown on a separate diagram.
Окей, Караульный. Ну, Хорватска. Ларби.
Yes, so I would agree that it will be better to show each alternative flow on separate diagrams so they wouldn't intersect.
Окей, Лицар. Мараренко. Окей, Сивак.
Yes, to avoid complicating an iteration diagram with forked control flow, it is better to split the diagram into several simpler diagrams or use separate diagrams such as activity diagrams to represent parallel behavior.
Окей, Степаненко Сергей. Ну, швец.
Yes, I can complete that to avoid overcomplicating an interaction diagram with fork controls. We should also use combined fragments sparingly, split into multiple diagrams, use references, and abstract details.
Окей, Чайка. Ну, Давидович.
Yes, I agree with the previous answers. So to avoid complaining an integration diagram with forked control flows, we should follow to next recommendation like separation of concerns and model as a complex and clarity moving alternative scenarios to their own diagrams keep the main interaction model clean and easier to read.
Yes, of course, it's better to show each alternative flow of control on a separate diagram. In this case, such particular diagrams should be considered as complex as one model of interaction. That's all questions for today. Thank you very much for your attention and for your answer to the questions. Your points for today. Albul 2, Bodnar 4, Гайтукаев 4, Горбатова 4, Ларби 4, Мараrenко 4, Сивак 4, Степаненко Сергей 2, Швец 4, Давидович 4, Балык 4, Малявка 4, Прохорова 4, Стогний 4,